In this video, I would like to continue solving problems that came in one of the IB high-level math tests. This question says that you have a quadratic equation given by x squared minus 2kx plus k minus 1 equal to 0 and has roots alpha and beta such that alpha squared plus beta squared equal to 4. Without solving the equation, find the possible values of the real number k. So, in this case, we have that alpha squared plus beta squared equal to 4, where alpha and beta are the real roots of the quadratic equation given by x squared minus 2kx plus k minus 1. Now we know that the general formula of a quadratic function is given by ax squared plus bx plus c. And in case when a equal to 1, then we know that the roots of this equation, alpha, beta, are such that alpha times beta equal to c and alpha plus beta equal to b. So in this case, we know that alpha times beta equal to c, which is k minus 1. So remember here, if you compare this to this, we have c equal to k minus 1, and we have b equal to minus 2k. And also we have alpha plus beta equal to minus 2k. So here we have a system of equations with two variables. So we have two equations with two unknowns, then we can easily solve it. Now, using this equation, the given equation that relates alpha and beta, we can add 2 alpha beta on both sides, and in this case what we get is alpha squared plus beta squared plus 2 alpha beta equal to 4 plus 2 alpha beta. Alright, and this, the left hand side of the equation, can be written as alpha plus beta, everything square, equal to 4 plus 2 alpha beta. Now using equation 1 and equation 2, we know that alpha plus beta is simply equal to minus 2k, which is equal to 4 plus 2, and alpha times beta is equal to k minus 1. So we can continue squaring this term. That's going to be 4k squared. Remember the negative sign, negative 2 squared is 4 plus 4. And then this equal to 4 plus 2k minus 2. So continuing, we can actually minus 2 with 4 is just 2. You can take the 2k to the other side and 2 to the other side, and we will have 4k squared minus 2k minus 2 equal to 0. Then what you can do is you divide the whole equation by 2. So we will get 2k squared minus k minus 1 equal to 0. And we can factor this as 2k plus 1 times k minus 1 equal to 0. So you can double check. 2k times k is minus 2k squared, plus 1 times minus 1 is minus 1. Then I have 2k times minus 1 is minus 2k, plus k give you minus k, which is this term. So this is correct. So two terms, the product of two terms equal to 0 means that either 2k plus 1 equal to 0, which means that 2k equal to minus 1, or k equal to minus 1/2. That's the first possible value of k. Another value is when the term k minus 1 equal to 0, this means that k equal to 1. So these are the two possible values of k. Now let's move to the next question. In this question, it's given that the sum of the first n terms of a sequence, so un, which is basically u1, u2, un minus 1, un, is given by, so the sum, Sn, which is equal to the sum from I equal to 1 to n of ui, equal to 3n squared minus 2n. So write down the value of u1. So part A, we want to find u1. To find u1, notice that if you substitute 1 in the index and s of n, this is going to be equal to the sum from I equal to 1 to 1 of ui, and this is simply u1. And then substitute 1 in here, you will get 1 squared minus 2 times 1. Now this equal to 3 minus 2, which is equal to 1. So u1, the first term of the sequence, u1 equal to 1. Part B, it's asking to find u6. So how do I find u6? So notice that if I have S6, I can write it as the sum from I equal to 1 to 6 ui, which is equal to the sum from I equal to 1 to 5 of ui plus u6. And clearly that this is simply S5. So I have now the following formula: S6 equal to S5 plus u6, which means that, rearranging the terms, u6 equal to S6 minus S5. But I already have the equation of S, so I know that S6 equal to 3 times 6 squared n is 6 minus 2 times 6, right? This is simply the equation here. And that gives me 3 times, or what I can do is actually I can take 6 as a factor first. This will be 3 times 6 minus 2. So it's 6 times, this is 18 minus 2, it's just 16. And the answer will be 6 times 6 is 36 without the calculator. 6 times 1 is 6, plus 3 is 9, so it's 96. And then I can find S5, which is 3 times 5 squared minus 2 times 5. This is equal to 5. Take 5 as a factor. This will be 3 times 5 minus 2. And this is just 15. So it's 5 times 13, which is equal to 5 times 3 is 15. 5 times 1 is 5, plus 1 is 6. So subtract these values, that will be 31. So U6 is equal to 31. Now, question C, prove that this sequence is an arithmetic sequence, stating clearly its common difference. In part C, so they want us to prove that the sequence UN is arithmetic, and if it's true, then we know that the sum of the first n terms of any arithmetic sequence is given by, there's a closed formula, n over 2 multiplied by 2a plus n minus 1d, where a is basically the u1, the first value of the sequence, so the first term, and d is equal to the common difference. So the question is, can we express this Sn in that format? So we know that Sn is given by 3n squared minus 2n. So if you take n over 2 as a factor, you are left with 6n minus 4. All right, so we can do some of the rearrangement. This would be n over 2, and then we will have 6n minus 6 plus 2. All right, so because minus 4 is just minus 6 plus 2, and then you notice that we can rearrange this and take 6 as a factor. So that would be 6 times n minus 1. So it's very clear that here we have 2 times 1, and 1 is just the first term, u1, and 6 is basically the common difference, d equal to 6, by comparing these two formulas. And we know that if these are the cases, so we know that the nth term can be written as u1 plus n minus 1 d, which is 1 plus n minus 1 times 6. And remember, we calculated before u6, so to double check, u6 was 31, so it's 1 plus 6 minus 1 times 6, which is equal to 1 plus 5 times 6. So 30 plus 1, that's just 31. And that's the complete of the proof.